So this is number 15, so which is a nice number theory question. So we are looking for a number m when you multiply with those factorials. So you will get the perfect square, but we are trying to get the least number possible. So like it's 16 numbers, actually 15 numbers given as factorial, which we don't really want to multiply them all. We just like to see what prime number doesn't have a pair, so we cannot have the like perfect power, right? So, but it's not really obvious, so which is why I kind of start with listing those. So that should be 2 times 1, and the next one is like 3 times 2 times 1, and 4 times like 3 times 2 times 1, and 5 times 4 times 3 times 2 times 1, and 6 times 5 times 4 times 3 times 2 times 1. So I'm going to write this way, but I hope that will give us some relation to see which ones will give us a perfect square. Okay, so 7 times 6 times 5 times 4 3 2 1. So you don't have to complete this like writing, so you can kind of see what's going on, but let's add more. So it's not going to take too long. Okay, so 5 4 3 and 2 1, and let's do 9 as well. So 8 7 6 5 and 4 3 2 1. So like you will continue this until you get 16, right? So like if you look at the power of twos, okay, so we have like twos on every single factorial. Since we start with 2, like we didn't start with 1 through 16, there are 16 numbers. But since we are missing the first number, so you have 15 of the, like numbers that you multiply, that means we have 15 twos. What does that tell you? So 14 twos will make a perfect square, and one of them will actually be alone. So I'm gonna just cross everything other than 1. So if I cross these, no twos left, okay? So that is something. But now for the threes, we have actually 14 threes. So all threes will actually make a perfect square because you have even number of threes. But now fours, we will get odd number of fours, which is gonna give us like we start with 4, like we are missing first 3 out of 16, which is 13 fours. So 12 fours will make a perfect square, but the rest will make the one of those 4 will be remaining. And based on this pattern, so you will see all odd numbers will have even number of times, which will make a perfect square. So you can just ignore them. And for the 9 and all the way to the 15 will be just perfect square because you are going to have even number of terms, right? For the only number that maybe you can just think about is 15, but 15 has a 15, but 16 factorial has also 15, so that will also a perfect square. So you will get 2 15s for sure. And for the even numbers, you are going to cancel everything except one of each, okay? So I hope that makes sense. Again, if this doesn't really make sense so far, please kind of go back and pause and think about the process that I just tried. And what we are going to left with would be 2 times, 4 times, 6 times, 8 times, 10 times, 12 times, 14 times, 16. And of these, like we are going to multiply the product to get a perfect square. But we can see this is going to be 8. This is 8 times 8, which is a perfect square. This itself was a perfect square. No need to deal with that. And then this is 6. So I can take the one of the 6 to multiply this y. So you will get 2. So that is gonna be only number that doesn't have any. And then if you take one of these twos and multiply with this, you will get 7. And then we have 10 and 7 left that doesn't have any pair to make a perfect square. So when you multiply all these, everything actually pair with another prime numbers to get a perfect square other than these two numbers, right? So to multiply these two by something else to get some perfect square, the m that we need to multiply by these two should be at least 70. So that is the final answer. So you don't have to really draw this like picture. You can just do the other way around or something different, but at least it is giving us a kind of pattern that is going on. some people actually see that pattern without having this kind of writing, but I hope that makes sense for us. Okay, so I'll see you in the next video.